Hello everyone, welcome back to the channel. Today we are going to discuss another LeetCode question, which is minimum time difference, right? So in this question we are given a list of 24-hour clock, right? Time in this format. We are given time in this format, hours and minutes, right? And we have to return the minimum minutes difference between any two time points, right? So let us say I have pick up these two time points from the list and I have to find the difference, right? So let us say this is a difference. This is a difference t, right? So in this case, I am having only two values, so the difference between the time would be my answer, right? But let us say I'm having another time t, t1, t2, right? So I have to find the minimum distance between all the pairs. I have to find the minimum distance between all the possible pairs, right? I have to return the uh, minimum distance, or you can say minimum time difference between them. So how can I approach the problem? So let us say I'm having a clock, right? So this is my clock, and let us say this is my time t1, this is my time t2, this is my time t3, this is my time t4, this is my time t5, right? So let us say I'm given these following times, right? So how can I approach, how can I convert this time into some standard form, right? Into the standard form. So can you think one thing, that let us say I 23:59 is my time, right? So do I know how many minutes are there in the, how many minutes does this time have, right? So what are the number of minutes here? So can you say that the hours into 60? So this I get the number of minutes from the hours, and I have to add this minutes. So I have to add this minutes. So this is the m, this is hour. So can I reduce that? If my time t is given in this form, if my time t is given in this form, the number of minutes is hour into 60 plus minute. Can I say that? Can I say that? Yeah, definitely I can say that. So one thing that I come that comes into my mind, that if I represent all these times into this standard notation, into some standard representation, and then if I calculate, right? So let us say this is my time t1 and I have found it as 20 minutes, or let us say 0, it is at 0 0, right? So it is 0, right? If it is 0 0, so what will be my value of minutes? So it would be 0, correct? Yeah. So if I represent everything, right? So let us say this is my let us say 75 minutes, right? So let us say this is 90, or let us say 120 minutes. Let us say this is 200, or let us say, yeah, I'm just 500 it is. I'm just taking it randomly, right? So let us say this is 1200. So these are the times that I am having, correct? These are the times I am having. Now can you see one thing, that the difference between t1 and t2 is this, t1 and t2 is this, right? But there may be a case, there are two paths. So this is one path, right? The difference between t1 and t2, and this is the another path, this is another path, this is another path. One is clockwise and one is anti-clockwise, correct? So there are two possible difference, and I have to find the minimum between them, because I have to find the minimum distance between t1 and t2, right? T1 and t2. So I can take the whole anti-clockwise path, right? And also I can take the clockwise path, correct? Correct. So there is a case. So let us say if I consider t1 and t5, t1 and t5. So what is the difference between them? So if you take anti-clockwise, so then your difference would be minimum, right? If you take this path, if you take this path, or let us say this, if you take clockwise, right? Sorry, if you take clockwise difference, right? So then your this would be minimum, right? So this is minimum, right? Correct. So T1 minus T5. So what is T1 minus T5? You don't have to take this whole path. You have to take this path. You have to take this path, right? This is CW. If you are subtracting T1 from T5, right? So it is anti-clockwise, right? So you have to subtract anti-clockwise here to get the minimum distance, right? Right. So what kind of thing you can find, right? So this is a cycle, right? So let us just break this cycle. Let us just break this cycle from here. So let us say I have extended my clock into some, I have break, see, as in when you are given cycle, you have to break this cycle, right? So I have break this cycle, right? And I am representing all my times in some kind of array, right? Let us say I have represented, put all my times in my array, right? Now I am having all the times, and I will be sorting it down, right? I am sorting it down. Why I'm sorting it down? Because I want minimum difference, right? If I sort it down, then I apply. Let us say this is my sorted values, or let us say this would be only my sorted values: T1, T2, T3, T4. I'm just writing it randomly, okay? So let us say this is my sorted value, or let us say I'm having T3 here and I'm having T1 here. So this is my sorted values, right? So what can you think is, uh, let us say I am having, this is my sorted values. Now if I apply the difference, the consecutive difference, let us say this is my consecutive difference. So I would be minimizing the consecutive difference. Let us say I got D1, D2, D3, and D4. So the minimum of this four thing is our answer. Correct, correct, correct. These are the differences, consecutive differences. Because if I sort it down, my problem breaks into, right, finding this the consecutive minimum consecutive difference, right? So what is the time complexity, right? So the time complexity for the solution, if you are sorting, right, so it would be order of n log n, order of n log n, correct? So can you optimize this further? Can you optimize this further? We will think that part, because see, the idea comes that if you are representing it into some kind of array, and what is the maximum value, what is the maximum value of minutes? So it is 24 into 60, that is 1440. So this is the maximum number of minutes I am having, right? So what is the range of minutes? So it is 0 to 1, 0 to this, 0 to this range, right? And how can you optimize this? See, I don't have to apply sorting on this n value. So let us say I'm having uh, uh, my n is, let us say 10 to the power 5. So I don't have to apply sorting on this whole 10 to the power 5, right? I can apply sorting on this number, and I have to design an algorithm that I apply sorting, or I apply kind of something, I apply sorting on only this size. Every time I apply on this size. So it would be somewhat like order of n, because if I traverse, right, and apply sorting here, so it would be breaking down into order of n solutions. So yes, I can optimize it, but how I can design an algorithm, we will think upon it, we will ponder upon it, right? So now let us just see the code for it. Let us see the implementation for this logic that I have just written. Yeah, but before that, yeah, there is a catch. There is a catch, right? So let us say in this edge case, let us say the first example, right? So what is the value of our array, right? So we have represented the time. Let us say this is T1, right? This is T1 and this is T2, right? So what is the value of T1? So T1 value is 23 into 60 plus 59. So if you calculate this, what would be our answer, right? So it is 80 and 1380 plus 59. So what is this? I mean 9 and yeah. So it is 1439, correct? So the value of T1 is 1439. 1439. And what is the value of T2? So it is 0, correct? So what is now, if you break it down, so if you sort it down, right? So it is 1439, right? So this is T2 and this is T1, right? So now there is a case that if you are subtracting it, you are subtracting 1439 minus 0. So what will be your answer? So it would be 1439. But as I said, you that if you are breaking this loop, this is my loop, right? And I have broken down into one array, right? So there may be a case that you have to subtract the endpoints, because see, these endpoints may be connected, right? I am breaking the loop. See, I am breaking the loop here, this is my clock, and I'm breaking the loop here, and I'm converting this loop into a linear line, right? So I have taken difference at all the breakpoints, right? But I have not taken the difference here. Right. So I have to do this thing. See, I have to do this thing. So let us say this is my answer, right? For according to this algorithm, this is my answer, right? But now, as I told you, I have to subtract and I have to find the difference. Let us say this is my clock and this is my 00, and this is, let us say, 2359. So this value is 1439, right? So this value is 1439. So what is the remaining value? What is the remaining value? So can I get this as what is the, see, total number of minutes are 24 into 60, which is this value 1440, right? Which is 1440. Correct, correct, correct. Now, if I know the total number of minutes, if I know the entire circle, and if I subtract this thing down, so can I get this? Can I get this? So if I subtract 1439 from it, 1439 from it, so can I get my answer? So in this case, our answer is 1. Answer is 1, right? So I have to minimize our answer. So what will be our answer? So answer is minimum of answer. So I have to design a formula, right? So what is the formula? So it is 1440 minus. So what is our or what you can say, this is our array, right? So I have represented in terms of array. So it would be ARR of, let us say, minutes of n minus 1. Correct, 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 because this is the endpoint, this is the cycle that I am breaking, this is the cycle I am breaking, right? So I have to subtract the last position from the first position, because if I subtract this thing, if I subtract this thing, that's and only then I can get this point, right? Okay, if I subtract, let us say, these are my endpoints. I want to know this distance. I don't know this distance. So what is our distance? So it is minus of minutes of 0. Correct? It is always going to be this, right? If you try run here, so it would be 1440 minus, what is it? Is 1439 in minus of 0 it is, right? So our answer is minimum of 1439 comma 1. So it would be 1, right? So I have to write here minimum of 1449, right? So this is the case here, right? Because I'm breaking the cycle, so I have to subtract, I have to check for the endpoints, right? I have to check for the endpoints. So can I do this? Can I do this? See, one more time I'll be explaining. So this is my cycle, right? This is my last point and this is my first point, right? This is my minutes of 0. This is my minutes of n minus 1, correct? I have checked all the breakpoints, right? All the consecutive breakpoints, but this is also consecutive. This is also consecutive, right? And for that, I want to know this distance. I want to know this distance, correct? I want to know this distance. So if I know this distance, what is this distance? It is minutes of n minus 1 minus minutes of 0, correct? And if I subtract it from the total minutes, if I subtract this whole thing from the total minutes, which is this, so I would be getting this answer. I would be getting this x, right? So this is x. And I have to minimize x and answer. So what is the minimum? So we will get our answer, right? Because I have to, as I told you, I break down my clock into consecutive arrays, right? And if I find the consecutive difference, I would be getting my minimum distance. But this is also consecutive. The endpoints are also consecutive, right? So now let us just jump into the algorithm. So see, this is how I have converted into hours and minutes. So this is nothing but the first unit. So see, I am given my time as this. So this is 0, 1, 2, 3, and 4. So right. So 0 and 1 are for my hours. So I have subtracted 0 to convert it into integer, right? And I multiplied it by 10, right? Because I want it on tens position, right? And this is for ones position, right? Right, I'm adding this as ones position, right? So it of 1 minus 0. Why minus 0? Because I'm converting character into integer, right? So I hope you know the basic syntax of C programming, how you do this stuff, right? Right, now I am pushing back. I'm building this minutes array, right? I'm breaking the clock into a linear array, right? And I have sorted it down. Why I'm sorting it out? Because I want minimum difference. I don't want n square. I don't want n square computation. I want this into n, right? The computation should be n. So this sorting would take n log n. That this would take order of n. Right. And now I am firstly I am checking for the endpoints, right? Firstly I'm checking for the endpoints, right? So this is what we have discussed. You can check it on the later part also, but I have checked it for first. But see now, as I told you, just minimize your consecutive difference. So this is the minimizing my consecutive difference, right? So I hope am I clear? And what is the time complexity? It is the order of n plus order of n log n. So it is roughly about order of n log n, right? And space complexity is order of n for this building this mini cell, right? So can we optimize this time? See, this n log n time? Can we optimize this? As I told you, I don't want to sort each and every. I don't want to sort each and every minutes. See why? Because I am having my time as this only. Total minutes are this only, right? So it may be repetitive. It may be repetitive. See, it may be repetitive. Right. See, I have completed one cycle. So let us say these are n by two terms, and other n by two terms are the same. Are the same. Right. I have got this n by two terms, and in my times point array, I'm given another n by two terms as the same value. Right. So if I found another repetition of the previously seen value of a previously visited value, definitely my difference is zero. See. See, please pay attention. If I found another value which is already been visited, if I found another value which is already been visited by the previous cycle, or let us say by the previous value, so for that case, my difference is always zero, right? Because I have to find the minimum difference. So what is our range, right? So what is the answer range? So our answer can belong from 0 to 1440. Answer is in this range, right? A minimum difference is zero and our maximum difference is this, right? So yeah, so this is how you can think of building your solution, and you don't have to sort it, right? Because the cycle is repeated. See, the cycle of answer is being repeated, right? And the values may get duplicated. The values may get duplicated. So you don't have to sort it down. So this is the thought process. This is the thought process, right? Because I am having the fix. So can you think an algorithm? Yes, of course. Of course. What sorting algorithm do you apply now? What sorting? I have to replace this sorting algorithm. So how can you replace this sorting algorithm? Yes, bucket sort, bucket sort. It's nothing but a bucket sort, right? Right. So how you can do bucket sort, or you can say counting sort. See, so it's very simple, nothing much to think of, right? Just think this thing in terms of a cycle, right? Just think in terms of cycle, the visited cycle, right? So let us say I'm having, this is my clock, these are my times given, right? These are my times given. So let us say in my times point array, I am given a value as, I'm given a value as t1, t2, right? T3, T4, right? So these are the values, right? Or and let us say another value I'm having. So T1, T2, T3, T4, T5, T6, right? And this is T6, T5, and T6 is again here. T6 is again in the second cycle, right? T6 is I am having in the second cycle, and again at that same position at which T2 is, I am finding a T7, right? So I am having another T7, right? Right. So this is my array, right? This is my array. Now, if I represent, right? So what can I do? See, I just told you one thing. You don't have to iterate, or you have to iterate, or you don't have to sort all those things, right? You don't have to sort all those things. But if you find, let us say I have visited this array, right? Now I am finding T7, right? I am finding T7. But see, T2 and T7 are both at the same position. So can you maintain a check that is this spot empty? Is this spot empty? Right? What I'm trying to say, what spot means? See, maintain the indexes, right, from 0, 1, 2 up to your minutes. Right. So let us say I'm having T1 here, T2 here, T3 here, right? And let us say I'm having T7 here, or let's say T6 here. So I have kept I have marked all my times in terms of a number line, instead of putting it in an array of size n. I am putting my array in terms of in terms of this range, right? In terms of only this range only. So the size of the array is always this fixed size I am maintaining array, right? And as and when T7 comes, my T2 is filled, T2 is occupied. So if I check that whether someone is there or not, is this position empty, right? The value at this index is empty or not. So T7 finds that no, someone occupied, right? So it will directly return 0. Why 0? Because the minimum difference between T7 and T2 is 0 because they are the same position, they are the same time, right? So the difference between the same time is always 0, right? So there may be a case if you find another T8, right? So let us say this T8 is equals to T1, right? So if you return directly here 0, so no need to check the later part, no need to check the later part of the array, right? Or of the given array, right? Right. So this is how you can optimize the things. This is how you can optimize the things, right? So this is the this is the case that you have to maintain, right? So now let us say I don't find T7, right? So how you can find the minimum difference, right? I am having all the unique values. I'm having all the unique values. So how, in this case, how you can find the minimum difference, right? So can you see one thing that my search space can never be can always be in this number line, right? It can never be here, it can never be here, right? It can never be here, it can never be here. So this is, so previously in previous approach we maintained an array called as minutes, right? We maintain arrays called as minutes, and we apply the minimum differences, right? So can we do one thing, instead of the search space previously was minutes, right? So here the search space is this much, right? Right. Because these are the times, right? So we have to search only this, right? You can also search from zero to whole array, but that, and you have to maintain a check that is this value holding some value? Is this value visited or not, right? So initially all the values are marked as 0, 0, 0, 0. So all the are not visited, right? And this T1, T2, and T7 are marked as 1, right? Or Boolean values, right? So this represents that they are visited, right? Right. So now for I have to find the minimum difference, right? I have to find the minimum difference. So you are iterating from T1 to T7. So let us say I am having my for loop I goes to minim plus 1, or let us say minimum to I less than or equal to maxi. So what is this minimum and maximum? So this is my maximum range. This is my maxi and this is my mini. This is my mini, this is my maxi, like T1 and T6. This is my minimum and maximum respectively. Now I have to iterate here. Correct. Now, previously, in the previous example, what we did? We did mini of I minus mini of I minus 1. Correct? We did this thing. So how I can write this? So can we do one thing? Let us say here my mini is T1, right? In this case, I'm having minimum, right? Right. So I am having, so previous, I will be maintaining a previous pointer. So what will be the previous? Previous will be minimum, right? So previous, let us say I want to subtract T1 and T2. So let us say T1 is previous and T2 is current, right? T2 is current and T1 is previous, right? So I have to maintain a previous. So that's and only then how can subtract, right? So here this is previous and this is current. So this is how you can think. Right? So I have maintained previous equal to mini. And what is my current? Current is always plus 1, right? Because this is range, right? So it is not always T1 minus T2. So let us say it is T1 plus 1, right? So this is the range. This is the value of, I am searching for the each and every indexes. The search space is T1 to T6, right? Search space is T1 to T6, right? So what will be in the search space, right? So T1 plus 1, T1 plus 2, right? So these are the indexes. So T2, now I found T2, right? T2 plus 1, right? So this is my search space. It is not directly that T1 and then the next element is T2. No. This is not the case, because I have represented in terms of indexes. I am searching for indexes, right. So that for this is the reason why mini plus 1 I have written, right. And now I will be just simply applying this algorithm, the same algorithm, right? Mini, or let us say answer, equal to minimum of answer, comma I. So this is the index minus previous, right? And now you can simply assign previous equal to I, right? For the second iteration, I am updating my previous. I'm updating my previous, right. Now, do we do when we will do this thing? When we will do this thing? If our visited is 1, is if our index, the value of our index, if our visited of I is true, that then and only then we have to do this thing. Why? Because see, if it is 0, so it was not marked previously, when we were calculating our times, when we were calculating our minutes, and we were representing in number lines, then we have to mark here, then we have to mark all this thing as 1, and this position is 0. So I don't want, let us say I am having our t1 is marked, let us say t1 is marked, and let us say t1 plus 1 is not marked. So this is not in my given input array. This time is not given in my input array, right? But I'm iterating through all the indexes in this range. I'm iterating through all the indexes, right. So yeah, this is the case. So for that you have to do this. You have to do this check, right? That your visited should be 1. Visited should be 1, because if let us say t1 plus 1, it is 0. It is marked as 0 because see previously what I'm trying to do. See, just a second. I must have written this code. This is the, but before this I would be marking all my time. So I would be iterating on my times points. This is my given array. Now I would be marking, or let us say I would be marking my minutes as 1. But before that I told you that if you find this minutes, if your visited of minutes is true, so someone may have visited it before. Someone, see, in the previous example, the T2 and T7 were equal. So when you are at T7, you found that T2 was visited by someone. So here you return 0. Simply you return 0, right? And here you mark visited of minutes as 1. Correct. So this is the simple thing that you have to do. That you have to mark this minutes. You have to mark this minutes, and you have to simply calculate minimum and maximum here in the same. Calculate minimum and maximum, right? For this iteration, for the next iteration. So first you have to apply. First you have to mark all the indexes for your time, right? And then you have to apply this algorithm only on those index which are visited, right? So what does this visited means? Visited means times in your input array. So these are the indexes which are also present in your input array. So this is nothing but visited array, right? So this is how your bucket sort works, and simply return answer here. Return answer. So let us just quickly jump on the code. See, this is the maximum value of visited. As I told you, my search space. These are my indexes, right? These are my indexes inclusively. So this is the search space that I have maintained, right? Right. So initially so this is the minimum and maximum initially, right? Now I'm iterating on the time points, and as I told you, in the same as the previous approach, we have calculated the minutes. But see, if someone marked your visited, if your visited is true, right? That means someone has marked that particular index, someone has marked this index, so that means you have got same time, you have got duplication, right? So t1 t2 was there, now you again found t7 at the same place, so this means this value is true, so you simply return 0 because the difference of the same value is 0, right. So here you have to mark your visited as 1. Yeah. If this condition is false, you have to mark this as 1, and this is nothing but I'm calculating the minimum and maximum. Why minimum and maximum? Because I'm searching in the minimum and maximum range. Right? Initially I'm searching from 0 to this. So see, this line means this. I'm searching from 0 to this. Now I'm updating my minimum and maximum. Now I'm updating. I'm reducing my range. I'm reducing my search space. And now this is the only range I have to search. Let's say this is T1 and this is T8. So I have to search only this range because I won't find any values here. I won't find any time here, right? So this is nothing but a minimum and maximum calculation, and this is nothing but a pre-computation for marking this as visited. So I have visited this value, right? Why I'm marking this as visited? Because in the second iteration, when I'm finding the minimum difference, I have to check that is this time in my answer, is this time in my input array, right? Because that's because see, let us say I'm having a time as 1 p.m. and another time as 2 p.m. But these two times gives me minimum distance of 60 minutes, right? And all the other time gives me minimum difference greater than 60, right? But I don't find these two time in my array, in my input array, right? So is this our answer? No, because we have to find a difference in this. Right. So 1 p.m. and 2 p.m. are not in our input array. So why do we want to find here? Why do we want to find the difference here? So this is the only thing that you have to do. So yeah. So what is the maximum difference, right? So as I told you, our range is 0 to 1440. So what is the maximum difference? So it is always this, always 1440. So our answer cannot be more than this value, right? So it is always going to be this. Right, so I've initialized it with 1440, and then my previous is mini, right? Why previous is initialized to mini? Because I want to do this thing. What we did was, I want to do this minimum of I minus minutes of I minus 1. So this is minutes, right? Sorry. So I want to subtract previous value, subtract the previous value. So for that, I have initialized the previous as mini, correct? Now I'm iterating from mini plus 1 to maxi, right? I am checking that if this is in my answer or the input array, if this is in my input array, that's and only then I'm updating my answer. I'm updating my answer and I'm updating my previous value, right? So for updating the answer, just simply minimizing my answer and I minus previous. So this is what we did. This is what we did, correct? And this is simply thus I'm updating my previous value, right? Right, for the second iteration, my previous is changed. My previous has moved forward, right? So previous equal to I, right? And now see this part that we discussed in the previous approach, right? That there may be a cycle, there may be a cycle. So let us say this is our search space, or yeah. So let us say this is our search space. This is our minimum. This is our maximum. So this is our search space. Now I've broken down this minimum. So let us say this was our maximum. This is our maximum, and this was our minimum. So I have broken my cycle into a linear line. So there may be a case that minimum and maximum, the subtract this difference, this particular difference can be our answer. This difference can be our answer. Right. So what I'm trying to do is the same thing that we did previously, the same thing that we did here, right? The same thing that we did here. That's what I'm doing. I'm minimizing my answer, and this is what? Why this? Because these are the total minutes t, or let us say total minutes minus, or let us say one direction difference. So this is nothing but a one direction difference, right? So if I subtract the total minutes from one direction, this may be any direction, clockwise or anti-clockwise, right? So you will be getting another direction, right? If I this is my one direction. Let us say this is my let us say clockwise direction. For an instance, this is our clockwise direction. So this is our clockwise direction, and if I subtract it from the total minutes, subtract this from total minutes, can I get the anti-clockwise direction? Yes, of course. So this is what I did, and I am minimizing it with answer, right? Minimizing it with answer because this can be a answer. I'm not sure this is our answer. This can be answer because see here, let us say if I find a difference of 1 minute, and if I find here the distance is let us say 60 minutes, right? So there may be a case. So this is how you have to find the minimum distance, right? So that's all from my side. I hope you have learned something new. And yeah, so yes, another thing that I want to discuss, instead of representing all the times as indexes, we represented all our times as indexes. Indexes. You can also use bitset, right? What is bitset? Bitset. So bitset. So let us say in the previous yesterday's problem, we use bitmask, right? So can we represent it? Can we represent 0 to 1440 as bits? Of course we can do. Of course we can do. So let us say normally we have 0 to 31. So these are my bits positions. These are my bits position up to 31. 0 to 31. So can we do something like in a special case I am having these are my bit positions but up to 1440, right? So these are my bit positions, and let us say if a bit is 1, which means that it is visited, right? It is marked as visited, right? But if it is 0, if the bit is 0, let us say this bit is 0, so which means, and this bit is also 0, so which means that these two times are not being visited and these two times are not in our given array, right? So yes, we can do that. We have to, but nothing but just a single modification here. If you want to use bitset, instead of this vector, you have to write bitset, and instead of int, you have to write a constant, which is 1440. So right, so you can write it like this. Let me write it over here. Bitset of 1440, and you can write it as visited, right? And you have to mark it as 0 because initially all is 0, right? All the bits are 0, so you can write it as 0. So this is somewhat you can treat it as an integer. You can treat it as an integer, but this works same as array. This works same as array. So you can write instead of, you can write the same thing. You can write the same thing, right? Array of minutes, right? So what does this means? So this means the bit position as this at this index, right? The bit position at this index, right. So instead of, yes, if you want to think in terms of bits, so you have to do bit set, right? Because normally we are only having 31 bit position, but here we are having this much bit positions, right? So yeah, that's all from my side. So thank you very much, guys.